Hello everybody and welcome back to another Java tutorial. Today we are going to be looking at Boolean operators, logical operators, and then some control flow elements. So the central theme will be true or false, is that pretty much that, and then how we can use those two states, 0 or 1, to kind of manipulate and control programs. So the first thing we'll do is Boolean operators. So Booleans, if you didn't know, it's a primitive type, so you just say Boolean B, and it takes up 1 bit of space. It's either a 0 or a 1, so it's pretty cool. It's better than C++ or C actually, because Booleans take up 1 byte of memory, but in Java they take up 1 singular bit. So Boolean B, and you can say E is equal to true, or B is equal to false, either one. Now with Boolean operators, you can use these operators to kind of assign some statement to a Boolean. So let's say we have a variable I, so we've already declared I up here, so I'm not going to say, or let's just say double D, or double D is equal to 3.14, or let's just say math.pi, because that's a variable in the math class. So double D is equal to math.pi, and there are a bunch of Boolean operators. So you have greater than, less than, greater than or equal to, less than or equal to, equals, and does not equal. So let's do this. So B is equal to D is greater than 3. That'll probably return true. B is equal to D is less than 3. That'll be false. B is equal to D plus 5 is greater than or equal to math.pi plus 5. So you can combine these with expressions to determine if something is true or false. Now let's do this with the character. So B is equal to, let's stay with the numbers for now. D minus 5 is less than or equal to 4, probably return true. And then B is equal to, let's use a character now, so A is equal to A, and then B is equal to, or let's say A is equal to, or let's define a character actually, so char C is equal to A. So C, so the character, the variable C is equal to the character A, and then let's say B is equal to C does not equal, so that the exclamation point is the not equals operator. Does not equal, say B. So these should, everything should be true here, I believe. Yeah, these should all be true. So what I'm going to do now is I'm going to create a breakpoint in the program, and in Eclipse you can debug and walk through the program step by step. So to do that, you just go to the debug button. It looks like a bug, so you click on it, and you can do private networks, whatever, and go ahead and switch to the debug perspective. So what you'll see on the right here is that it gives you all of these variables now. So once it gets to the breakpoint, we see B is equal to false right now, because that's the last thing we set it to. So B is equal to D is greater than 3. That should be true, so I'm going to step over this button, so that'll go to the next statement. B is equal to true, still equal to true, 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 and true. So just like that. So yeah, those are your operators there. Now let's do some logical operators. So with logical operators, what you can do is you can combine or modify the Boolean operators. So let's say that we wanted to say the Boolean value of B depends on that the double D is equal to 15.43 and I, which is an integer that we defined above, is equal to 6. So we want the Boolean value of B to depend on two variables at the same time. So we can say B is equal to, let me just say what they are up here. So it's and for both have to be true, or for either one is true, and then not, which just kind of flips what's there. So if it's true, it becomes false. If it's false, it becomes true. So let's just do this. So let's say b is equal to d is greater than 10 and I is less than, or I is equal to 6. So this should return true. We'll debug it later. Let's say b is equal to d is less than 10, which will be false, and then or I is greater than 1. So this should return true because just one of these is true. If both of them are false, if I said I is less than 1, then both of these would be false right here. So this would return false. So yeah, this will be false in this case, and then it'll be true if we say I is greater than 1. Now for the not, what we would say is b is equal to, put the exclamation point, then in parentheses put your statement. So we'll say d is less than 10. So what this should return is true because d is not less than 10. So the parentheses will be false, but the not, the Boolean not, flips that to make it true. So if we debug this again, we should get all trues. So b is true, true, and true. Perfect. Okay, so those are your logical operators there. Once again, you can use those to combine your Boolean operators. So less, greater than, whatever, all the way over to not equals to. So now let's look at how you can actually use these, not just for setting Boolean values, but for actually controlling the flow of your program. So we're going to look at if statements. So if statements are essentially a collection of cases that your program will run through, and it will determine which block of code to run. So we're going to define this block of code using an if statement. So if, and then in parentheses you put your case here. So we'll say if d is less than 10, we will system.out.println d is less than 10. And if we run this program, we should get that it doesn't print it out because d is not less than 10. What you can also do is you can say else, and this will return, this will be run if none of these conditions, if none of the conditions above are passed. So else system.out.println d is not less than 10. So you'll see it'll print out d is not less than 10. Now, what about an else if? So if you wanted more conditions, we'll say else if d is equal to 10. System.out.println d is equal to 10. You don't need to have all three. You can have just an if statement. You can have, but the if statement always has to be there. The else, then these two do not have to be there. The else statement is not required, but if you don't have an else, be careful about variable initialization. So I'll give you an example right here. So let's say int j is equal to j, and we won't initialize it. So if d is less than 10, I'll say j is equal to -1. If d is equal to 10, I'll set j is equal to 0. But for else, I'm just going to delete, I'm going to comment out the else statement right now. And what will happen is this j value won't be anything. So if I try to print it out, so system.out.println j, I should get an error. And you see errors exist because it says the local variable j may, this is a compiler time error. So the program knows that j may not be initialized, so it'll just stop you in the tracks. Because it doesn't, in all of these cases, there's no else statement, so none of these cases are guaranteed to run. But with an else statement, at least one of these statements are guaranteed to run. So one of these blocks, rather, is guaranteed to run. So now if I run it, we should get, oh, well, I don't initialize that, and then I'll say j is equal to 1 in the else statement, and we should get j is equal to, and then we print out j, we get a 1. So that's that. Now for, so that's kind of the if statements, and you can use these operators here. So you can take these statements, you can combine as many as you want. You can do d is less than 10 and I is greater than 6. You'll see, and you can combine them. You can do or statements. You can combine as many as you want as long as what's in the parentheses returns a Boolean. When we learn about functions and methods, we will also be using those in if statements. Now while loops functions pretty similarly. So while, and then you have a condition inside the loop. So every time, so let's say while d is greater than 6. So this block of code will run for until d is not less than 6. So what happens is, in a while loop, the code will get to this block, it'll see the while loop, it'll evaluate the statement. If it's true, it goes through the block of code. Then it goes to the top again, evaluates this if statement up here, and then does it. So kind of think about it like this. Let's just say system.out.println d is greater than 6. And then I'll subtract d, I'll decrement d by 1, just so it actually stops at some point. So if I run this, we should get d is greater than 6, 1, 2, 3, a couple times, because d is, what, 15, so I don't know, 9 times. Or I don't know how many times that is, but d is greater than 6 that many times. And then every time it decrements it, we can say, we can print out d as the value. So we'll say d plus, and then in a string is greater than 6. And you'll see that 15.43 all the way to 6.43 is greater than 6. If you want a more visual representation, or not a visual representation, but a more methodical representation of how this actually works, is you can think of this code as repeating as many times as you want. So this is essentially just a bunch of if d is greater than 6, system.out.println d is greater than 6. Just like that. And then you keep going. You do d minus minus. And this code will be run over and over again, but the thing is, you don't want to copy and paste this many times, and also you don't know how many times it will be greater than 6. If it relies on something like user input or some variable that is not known at the runtime, then it'll be, you can't really predict that, so you'll have to use a loop. One thing that I did forget to say is, if you had in the if statements, if you have multiple if blocks like this, the if blocks will all, the program will pass through all these if blocks here. So if true, system.out.println true 1, it will then keep going through the if statements one at a time. And I'll just comment this else if statement right now. So what you'll just see here is it'll print out, errors. Okay, so I'll just comment this, I don't care. So it'll print out both trues, but if you only wanted to print out one true, all you gotta say is else if, and then else if, and it will stop the if blocks until, or it'll stop the if blocks once it goes into one. So once it evaluates one of these as true, it'll only print out that one, so you only get one true this time. So yeah, that's how the if statements work rather than else if. But all of these blocks must start with an if. Cannot start with an else if or an else. Now for loops, what we can say is this is the format for a for loop. So you have for, which is the keyword, and then in parentheses you have an initialization statement, semicolon, then some sort of check, or so check essentially. It's kind of like the condition, or I'll say condition, and then a post iteration step. So what happens is, in the code, the compiler will find the for statement, it'll run into it, it'll run the initialization statement, it'll check the condition. If the condition is true, it'll go into the block. Then once the block is finished, it goes to the post iteration step, and then it goes back to the condition. If the condition is still true, it goes through the block. So it's kind of like a while loop, except it adds more compatibility in the manner that you can kind of control what's incremented. So the equivalent of this while loop up here would be for d is equal to 8, d is greater than 6, d minus minus, and then system.out.println d is greater than 6, just like that. And you'll see that we have put the initialization, the check, and the post iteration in one line. So what will happen is it'll be the exact same. So it'll run it twice because 8, then 7, and then 6. So yeah, this is just an alternative, especially if you're like going through steps, or when we get to arrays, these for loops will be helpful. If you wanted to do like a graphing calculator, you would go for x is equal to 0, x is less than 100 per se, x plus plus. And you can put multiple conditions in here. So we can say d is greater than 6, and let's say Boolean is running is equal to true. So you can combine the statements, that once again, as long as it returns a Boolean and is running. And you can also combine statements in the initialization. So we can say d is equal to 8 and integer f is equal to 5, or float f is equal to 5.0 float. Like that. You can, does it not allow you to do that? Oh, you can only do things of the same type here. So d2 is equal to 7 or 6.54, like that. Doesn't like that? Oh, okay, I know. Because it wants the type at the beginning. So double d1 is equal to 8, and d2 is equal to 6.54. So you can initialize multiple variables of the same type. You can have multiple conditions, and then you can also have multiple post iteration steps. So we can say d1 minus minus, and then I believe this is, and then comma d2 plus plus. Yes, you can combine statements up here with a comma. It doesn't make sense, but the comma is there. And you can also say, if we want to say and d2 is less than 7, we should expect this to run only once. So d is greater than 6. That runs once because d1 is equal to 8, so it'll be greater than 6 for 2 iterations. And then d2 is equal to 6.54, so it'll only be less than 7 for a single iteration, because once it's incremented, it is equal to 7.54. Now these last two are less known, I'd say. They're more obscure, but they're still pretty cool. So the do while loop. This is what you want to use if you want the loop to run at least once. So the format is do, then your block, and then while, and then your condition. So we'll say while is running. And you have to put a semicolon, or yeah, I think you have to, and then we just can define Boolean is running. So what you might be wondering, well, if is running is false, this loop should not run. However, it will run at least once because it gets to the do, it runs the block, and then it checks the condition. So even though is running is set to false, this will run at least once. Is running, and it runs only once. A quick note on these loops here: you can have infinite loops where the condition is never false, so it'll just run over and get a stack overflow. So try to avoid that. Use your while. Like sometimes you'll see programs use like a while true loop, and the break condition. I'll give you that keyword right now. You can use a condition called break. Let's actually do switches first, and then I'll do break and continue. So switch, it's pretty simple. You just test multiple. It's kind of like a condensed if else statement. So switch, and you put the variable that you're testing. So if you want to do multiple if statements for the same variable to test the value, so switch for I. What is the value of I actually? I is 6. Okay. So we'll say you put each case using case. So case, and then you put the value. So case 1, system.out.println I equals 1. And then to stop the case, you have to say break. Then case 2, system.out.println I is equal to 2. And then break. And then for if you want an else, you just say default. So this is the default case that runs no matter or runs if it doesn't pass through any of these cases, and you say system.out.println I is equal to question mark, and then break again. So you can run this, and you should get I is equal to question mark, so it gets the default. Now, what would happen if I remove the break statements? Oh, I guess in Java this doesn't work this way. Yeah, that's actually kind of weird. Huh, okay, I guess in Java this doesn't work where it falls through. Or, oh, you know why? Because it gets into the default case and then it just goes there. However, if I is equal to 1, it'll fall through. Like this. So then you'll get I is equal to 1, I is equal to 2, and then I is equal to question mark. So if it passes this case here, you get I is equal to 1, 2, and then question mark. Now, this is something cool here is like you can do a countdown. So let's say I is equal to 10, or let's leave it at 5. You can say case is equal to case 5, and you can print out 5. Then 4. So case 4, print out 4. Or you know, let me just put another. I'm just going to put another, create another switch. So I is equal to 4. So let's say switch for I again. Case 4, system.out.println 4. So then 3, 2, 1, and you'll notice that you get an error if you define the same case twice, just because it doesn't like that, because you can't run 2 blocks with the same case. So what will happen is if I is 4, we run it, you get 4, 3, 2, 1, 0. Now if I want to start the countdown at 3, just set I to 3, you get 3, 2, 1, 0. So it's something kind of cool. You could do a countdown or whatever. So yeah, that's what would happen if you remove the break statements. Now back to the other loops. There are 2 keywords that you should know: continue and break. Break means stop the loop, no matter what the condition is. So if I said here, while d is greater than 6, let's say I wanted the variable j. So j, I believe, will be equal to 1 here. So if j is equal to 1, I want to break. So instead of saying this value is greater than 6 how many ever times, it's only going to print it once. And it prints 15.43 is greater than 6, and even though d is still greater than 6, j, this condition passes and it breaks the loop. Now for continue, what that means is it'll simply just skip over the loop, skip over the rest of the loop, and go back to the start and evaluate the condition again. So the way you can do that is, what's an example? I'll say d2 is equal to 4.54, and if d2 is less than 5, continue. Here, let me just change this to that to 4, and this to 4, so I can differentiate it. So instead of it printing out d is greater than 4, let me just remove this right now so you guys can see what it looks like without. So it prints out d is greater than 4 3 times, because it runs the loop 3 times. Now if I add that continue statement, it'll only print it out twice, because 4.54 d2 is less than 5, and when it runs to this, it continues and goes to the post iteration step, and then to the increment, and so on. So yeah, those are the keywords that you can use with loops. You can use them in any loop, the for loop, the while loop, and the do while loop. Yeah. So yeah, that's pretty much it. That's Booleans, Boolean operators, logical operators, and then control flow, if statements, while loops, for loops, do while loops, and switches. So I will see you guys in the next video where we look at methods.